Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we will solve another question from Leetcode. So let's get started. Where our question for today is. Okay, so today we have a quite awesome questions. That is like one of the favorite topics for me, at least for interview perspective. So let's read out the question first. So the question named as zero array transformations 2. So what it is given to us, you are given an integer array nums of length n and a 2D array queries, where queries I stands for li, ri, val I. So it's pretty clear, right? So there is an integer array nums is given us, and we have a another array of two dimensionals having li, ri, and val I associated to it. It has li, ri, and val I associated to it. Each queries I represents the following actions on nums. Each queries of I represent the following actions on num. So using that query, we can perform certain operations of our nums. What we can do? We can decrement the value at each index in the range li, ri. So this is your l, this is your r. So what you can do? You can decrease the value from range li to ri with amount 1. You can do so. You can decrease the value from li to ri with val amount which is given to us. The amount by which each value is decrement can be chosen independently for each index. Now you don't have to decrement. Let's suppose here, not take this example. Now let's suppose this example. So from 1 to 3, so we have a range from starting from index 1 to index 3. So that means index is going to be start from 0, 1, 2, 3 like this. So from index 1 to 3, you can decrement the value from index 1, 2, 3, this triplet of elements with value 2. So here it is mentioned at most 2. You can decrement with value at maximum 2. But let's suppose you have applied operations to decrement index 1 with value 1. You have decreased index 2 with value 2, and you have decreased index 3 with value 1. Let's suppose you can do. So that's it is stated in this statement. So now from L to R, when you are processing a particular index, you can either decrease with at most the value is given to you on that particular range, or you can arbitrarily decrease. You can choose, you can decrease by 1, 2, or whatever it is, but at max you can decrease it with val. That's the fact. I think it's quite explanatory. You guys got this point. Then a zero array is an array with all its elements equals to 0. Now they have proposed there is a concept of zero array where all the elements of the array is equals to 0. Now how it is going to be beneficial for us? Return the minimum possible non-negative integers k such that after processing the first k queries, after processing the very first k queries in sequence, nums becomes a zero array. So they got the definitions of zero array. So zero array means all the elements is 0. Now we have to make the given nums to a zero array so that each elements of the nums is equals to 0. How we can do so? We can use the queries. How we can use the queries? We can choose we are going to tell that we can use the first, let's suppose first two queries, and I am going to use the first two queries, and I am able to make the entire nums to a zero array. So then what is the minimum queries I can use so that my entire array is become 0? And now the point to note here is we have to use the first k queries. Now the k value we have to return. The first k queries. First, how many queries? So that is a query. That is another query. That is another query. That is another query. Now like this way, how many queries in total we can use to make the entire nums array to a zero array? Now there can be cases like we are not able to make the entire array to a zero array by using all the queries. There can be possibilities. So if that is so, then in that case you can return a -1 for that cases, right? Yeah, I think the question is pretty straightforward. That's all about the question. Now the brute is going to be very simple. Now there can be multiple brute. I am not going to explain every brute to you guys because the brute is very trivial. And here you can see like nums of length is 10 to the power 5. Nums of I can be 5 into 10 to the power 5. Queries length is 10 to the power 5. Queries I of length. So that means each queries have three elements, one left, right, and val. So that is of 3. But The range from left to right can be again nums of length. Now nums of length they have given is 10 to the power 5. So everything is the range of 10 to the power 5 only. So that is the fact. That is the fact. Now when everything is on the range of 10 to the power 5, right? When everything is on the range of 10 to the power 5, that is trivial. That is obviously is a not a very straightforward question. Now I am going to directly tell you the exact optimal solutions, because there can be multiple brute, and none of the multiple brute is there can be of, you can write is n to the power 4, you can write it n cube, you can solve it with n square, but yeah, all are in time wasting, so I'm not going to explain that. So but you can try. Obviously one brute I can tell you that you can just take, if you can start processing every queries like from 0 to 2, you go to from take 0 to 2, you processed every you are trying to decrease every elements by 1, what is the maximum value to given to you, and like this way you can try to make every queries to apply, and when you have done applied to a particular queries, you can check if your nums is equals to a 0 array, and if it is so, then you from that points itself you can return a number of queries you have processed till now. So that is your answer. But yeah, that is going to be taking quite a lot of time, guys. That is hell lot of time, so we are not able to interested to solve that. So yeah, let's understand the optimal solutions. So the optimal solutions is lying on binary search. So frankly speaking, like this on that questions, we have put a joint effort, like the binary search ones I am able to think of, and so that is the concept of binary search on answer. And what is the possibility functions? So that is actually the code or fundamentals or brain of the entire solutions. That is all that has come from my wife said. So hats off to her. So yeah, now understand how we are going to solve it. So actually now let's jump to our OneNote that we are usually do. So binary search on answer. If you not know this topic, then please try to read it, but I will give you a like complete gist altogether to this question itself. So no need to worry. यार इसका बहुत रोना चलता है, यही दिक्कत कर देता है बहुत सारा. रुको अभी लिखते पर अभी लिखना हो रहा है. So let's suppose that is your queries given. So point to note, that is an offline query. So queries can be of two type. Let me explain. One is online queries and another one is offline queries. What is the difference between online and offline queries? Online queries, when the queries are given to you to a particular test case basis. Now you like test case writer given you a query and want to ask, by using that query can you form your answer? Then again they throw another queries. They again will ask you, by using these queries you can you can provide me the answer. So this is a kind of online queries. But and offline queries on the other hand, all the queries is given to us. That is a very starting of providing any answer. All the queries is given to us. So in our question, it is an offline query. So all the queries is given to us at the very starting of the question itself. So that is a kind of offline query. Now understand, like if I have the queries, so let's suppose there is a Q1 here. So now Q1, Q2, Q3, Q4, Q3, Q4, Q5. Now let's suppose we have 5 queries given to us, and yeah, obviously like Qi is something like of Li, Ri and val I for sure. Fine. Now I am stating you, by using Q3 you are able to build a 0 array. Let's suppose by standing at this index, you are able to build your 0 array. Let's suppose by standing at this index, you are able to build the 0 array. Correct. So can I say, using this also, using this query also, and if there are multiple queries after that also, using that also you are able to build the answer? I can say, right? I can say for sure, because if I am able to use this minimum set of queries, then using more queries, I am able to build the answer, because for that query, whatever the LR and val given to us, I will consider val to be 0. I am not performing any operations altogether for this query, and if there are more queries. So if I can pinpoint from which particular index, after taking that, we are able to build the answer. We are able to build our answer to be a zero array. Which particular queries? Just taking which particular queries. Then after that queries, so that is actually the beauty of binary search or answer. So there is two things: a portion of invalidity, a portion of validity, a portion of invalidity, a portion of validity. So from this particular portion, this particular portion is a portion of valid, and this particular portion from Q2 to very left is a portion of invalid, right? So that is the fact. This portion is portion of invalid, this portion is portion of valid. So when we have something like this monotonous portions, after that answer is always valid, below that answer is always invalid. So on that point, your brain should be capable enough to think about binary search on answer. So if you can pinpoint that particular portion for which your answer is just starting to make himself as a valid answer, that is your answer on this case. That is your answer is this case. As simple as that. As simple as that. Because if you have a portion, and you know entire right valid, entire left invalid. So when we are standing, let's suppose this particular mid, and if you get something like valid, okay, then right to also is going to be valid. If then let's search for what is the lowest valid. What is the lowest valid? I know that is going to be my answer for sure. But can I shrinking the window? Can I shrink my search scope? There is still a valid with lower elements taken. Can I make it also valid? So that is the case. I am going to, from here, I am initially my right pointer at here, I am moving my right pointer to this minus this. So my right pointer is going to be mid minus 1. And if my mid is pointing to something like this, where I got my mid equals to invalid, so I know for this left portion to altogether invalid. Let's then search for the validity to its right. Then on that case, my left is going to be mid plus 1. Then on that case, my left is going to be mid plus 1 for sure. That is the binary search I altogether written over here. Then the black box I am going to explain you. Let's not rush for that. I will giving you a proper dive deep on that. But yeah, first understand this process. So I have taken a length of queries L0 R QA minus 1. Answer to be initially I have declared is minus 1. Now I do the same things, exactly same things what I explained you. My left is less than equals to right. I think on last video also I have giving you the taste of binary search template of mine. So mid is going to be left plus right, right shift by 1. So that means left plus right divided by 2. Is possible functions is going to be do what? I will going to be explain. Let's consider is possible function as a black box for now. Now my answer is going to be, so if that is a possible answer, then I am storing this particular. So now it is mid is pointing to an index. Now they ask you how many queries we have to use. So index we all know it starts from zero based, but in terms of like count it should be 1 based. So to make it 1 based, we store this mid plus 1 as an answer, and we have shrink our search scope from right to mid minus 1 because that is a point of validity. Okay, then can we get something better by moving our right pointer to just mid minus 1? If we can get if we can get something better answer, something smaller answer, something smaller valid answer, that should be my answer then for sure. Then let's do for search for that. Let's make a search. If we are not, then we have already updated our answer. There is no issue. But if we get, then that should be my updated answer. So I have to search for that. So I make right equals to mid minus 1. And if it is not, then that is a point of invalidity. Then it's altogether left is also a point of invalidity. So don't need to search for altogether left. So whatever your current left, let's make it to search from left equals to mid plus 1. Mid plus 1, you may be some point of validity, but till your left, considering you and your left, there is no point of validity altogether. Correct? Now that is the case, and finally we are returning our answer. And on this case, if we are altogether able to find the point of validity, then our answer is going to be updated, and if it is not, then answer is minus 1 for sure. So that case, the last case is by default is going to be handled. If there is no such key exists, then we are returning minus 1. Now let's understand what we have written on is possible functions, because that is the brain of the entire code functionality of our question. So is possible functions, we pass our mid. So that means by choosing first first boundary. So mid is actually the boundary. So we are stating by choosing this many queries, can we build our answer? So for sure, this function is going to return us a bool. What it is returning us? A bool. It is returning us a boolean. So it is how it is going to be calculated. You provided a boundary with starting from very first from the queries to this particular boundary. Can we build an answer by using that many queries? Can we make our nums to a zero index array? Can we make our nums to a zero index array? That is stands for that purpose only, right? Now how we are doing so? How we will do basically do so? So we have like figured out. Let me just quickly explain, because on code level explanation I am not getting the feel actually, man. So let me explain on whiteboard first what I am looking for here. So now this is a quite, I have to say it is a quite difficult to going to explain, and for you if you are consuming on the first go, it is going to be literally difficult. I personally feel so. So let's consider your left. Let's consider a particular queries. A particular queries has a left, right, and a val associated to it. Now this is your nums array. This is your nums array. Now let's suppose your right is always to be very end. It's like right is always to be end. So that means starting from this, let's suppose your left is at here. So starting from this left to very end, you are able to decrease the elements with amount val at max val. Again, let's suppose there is another query with some L dash, R dash and val, and I am considering for यार इस पे इतना छोटा जगह है ना साला, लिखूं कैसे? So from this R dash, I am considering it's for every cases it is as an end. For every cases I am considering it is as an end. ठीक है? So let's suppose that is our L dash. So from this L dash to very end, we have a liberty to decrease the value with val dash. We from starting from this index to this index, we have the liberty to decrease the value with val dash, and starting from this index to very end, we have the liberty to decrease the value with val. So starting from L dash, what is our resultant liberty to decrease the value? So our resultant liberty is val plus val dash. So that is going to be an addition, because we are carrying something. We are carrying a power of val till this point. Till this point we have carrying a power of val. But this particular index, there is another guy arise from this particular L dash index with power of val dash. So there he is basically stating, hey man, you have the power of val dash also to decrease from that particular index to vary of its right. Oh, that's so. Then why not I am going to update my val to my carry, whatever the carry till now I am carrying, why not I am going to add with val dash plus. What is the carry I am taking? I have added plus equals to val dash. I have added more power to it. And let's suppose I got another L dash dash with power val dash dash. Then from that particular point, I am going to increase my carry more with val dash dash, because from this particular portion, my power is val. My power is val plus val dash plus val dash dash, right? So that is going to be the actual you have eagle eye, I have to say, you have to put to solve this question. Every particular L has bringing a new power to your carry. Every L, when you are processing it, is adding a new power to your carry. So from that particular index, your liberty to decrease the index which is more equal to or more starting from that particular L boundary is going to be your more power to your carry. So if there is more powerful elements from starting that particular index, your power is also going to be increased to decrease it. Now how are then going to be helpful? If you understood till this point of how we calculate carry is going to be plus, then make your brain to think if how R is going to impact the carry. Your brain should be capable to think. If you are on the correct, if you are able to think so, how carry is going to be updated when R is also in the picture, then I am going to state you are on the correct boat. You are very close to make it happens to a good company. So please pause the video currently and try to think how R is going to impact my carry. So till now, every time I am stating, when I am defining an R, I am putting R to be variant for you guys. To make it simple, I am putting R to be variant. But if R is in picture, then think once how it is going to be affect your carry. I think you have paused the video and think so. So let me explain how R is going to be affect your carry. So if R basically now stating, hey man, your liberty to use the carry, the powerful carry you are bringing from very start is going to be aimed at particular this index, is going to be aimed at this particular R index. Oh, okay. I think so. Okay, I think so. So after on this particular R, so you can use, but after R you can't use. After R you after R you can't use. So then I processed my carry for that particular index. Then after that, if there is an R is going to be, if I have an entry of R, if I know what is the, if for this R, what is the value, they basically snatching from my carry so that I can't use further. If I can get so, then I will minus equals to my carry with this particular value, right? And after next index I can use the updated value, because the very R index where it has the last survival power, like this is the very last where you can use me, and after that you can't use. So I have already used that particular R, and after processing that index R I have also so after that I have decreased my carry with val amount. So for next index it is use the updated carry. My carry is also going to be updated on the last index where I have an entry for R with value, with snatching value. Now I think you guys, so that is the entire concept. And so now carry is going to give what information? So carry is going to give you the informations what is the maximum subtraction you can make to a particular index. What is the maximum subtraction you can make to a particular index of your nums? So now if when you have a carry for a particular index and your nums of that particular index has more power, not greater than equals to, only greater than, not greater than equals to, then carry, then your carry is altogether not process. Carry is altogether. So you are using the very extra power, and using that very extra power also, your num size is more powerful than carry, right? Your num size is more powerful than carry. So then that num size never going to be at a of zero boundary. So they should be always in the positive boundary. You should not be able to do so. So if that is so, then from that points directly return a false. You don't have to process for that. If you got any index where your nums of I is more than your carry, return a false. And if you are successfully do so, then return a true from at the very end. Yeah, I think I am able to explain you. Now let's go through the code once. You will get the taste how we have implemented it. So we have initialized one dictionary LD and RD, which is basically storing basically that particular index. So let me explain it to you guys. So we are iterating to our queries till boundary of 1, because we passed here the index. So if we include that index, we have to include +1, so that this particular boundary is going to be in our range. Now we have left, right and val for the queries of IT, and we have done LD of left plus equals to val, RD of right plus equals to val. So we have cumulatively add whatever the value. So if there are multiple zeros, like here you can see, so one boundary starting from, okay, say, so they have given the identical entry from 0 to 2, you have the liberty to decrease 1, and again 0 to 2 they given the liberty to decrease 1. So we can say from 0 we have the liberty to decrease any elements with 2 power 1 plus 1. So we did a LD of left plus equals to var. So from this particular index 0 we have the liberty to decrease it. First it is going to be updated with 1, and then it is going to be updated with 2, and same we did for right. Now we started our carry. You will get the test how LD and RD is going to be help us. Now we have started our job from I in range n to the nums array what is given to us, and if I in LD, if that particular index is present in our LD, that is of left boundary, if our left boundary holding that particular index, then from that starting from that particular index, whatever the carry we are carrying, we getting a more power from that particular index. And what power you are getting, man, that is going to be vended out by your LD of I, which we already mapped it in the last iterations. We already mapped it in our last iterations. So our carry is going to be more powerful with LD of I, and that is the case that I just explained you. If at any point your nums of I is more powerful than carry, so using your extreme power, you are not able to decrease the carry. You are not able to decrease the nums that of particular index. Then on that case, you can return a false altogether. And now before going to your next iterations, you can check if that is the last, if any particular carry, you maybe carry LD of, you maybe carry of L dash, L dash dash, L dash 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 dash, like this, so you can carry multiple L's. But if there is an R is going to be ending to that particular index, you have to check it, right? You have to check it. So you are going to check if my RDs also have an entry for that particular index. If any of the carry is going to be, any of the val, more specifically I have to say, is going to be ending to that particular index. Oh, someone is there which is going to be ending at particular index. So then my carry power is also going to be decreased from the very next. I already processed, I have to say, for this particular index. But for the next go, can I make my carry to be decreased with RD of I? I should, right? I should. So I did so, and after that, by using this for loop, if I never encountered to this particular block, then that means I am using the queries till boundary. I am using the queries till boundary. I am able to make our nums entirely a zero array. And if it is so, then why not I am returning a true? And if I am not able to do so, then from that particular index, I might be already returned a false. Right? And that is our is possible functions altogether. Yeah, that is altogether the test of this question. That is a very, very, very beautiful question, and I have to say that is more than a medium level question. If on an interview that is asked, and if you are explaining this question to that much clarity, then there is no any chance to someone reject you to that interview. You are like the father of that particular interview. That I obviously have to say. Yeah. Now we are at the very end. Now quickly discuss the time complexity. Now I am pretty sure if you guys following me till this point, and if you are understanding this entire concept, then time complexity you can write your own altogether. So the time complexity we are iterating here, I can say n at max, maybe boundary can be at n, and here I am iterating for sure of n. So here I am on the naked eyes, I can see 2n, and binary search and what is the, we are doing binary search of queries length, and what is the maximum queries length? Queries length can be maximum of 10 to the power 5. So we can say if I can consider queries length QL, so QL stands for queries length. So we are doing 2 into n kind of complexity here, 2 into n kind of complexity when we are doing is possible functions within the is possible functions, and before calling is possible functions, we are doing a binary search altogether with log of QL, what is the queries length. Right, so that is our time complexity, is something like this in mathematical term, 2 into what is our maximum, tell me guys, what is our maximum n is of 10 raised to the power 5 into log of 10 raised to the power 5, that can be max. Right, you can calculate it, whatever it is, that is the time complexity at max, worst case time complexity for this question. And space complexity is, I have to say, yeah, we are using a dictionary, and there can be duplicate entries. They can put a duplicate entries of every queries from, yeah, like every queries they can make a duplicate entry. They can do. they are doing here. So yeah, that is also of big O of n only. So big O of n or big O of 2n? Big O of, so big O for left, if we have queries of length QL, and for every QL there is an L, there is an R. So yeah, I have to say big O of 2 into QL. I think you guys got it. So 2 into QL, one is for like left entry, one is for like right entry. That is the space complexity for this question, right? So that is our final time and space complexity for this question. And if you guys understand till this point, please do subscribe to our channel, and please turn on the notifications to get update to our next videos. Yeah, and weekend almost came, and tomorrow we have a holiday, so wish you basically an optional holiday for sure, so for Holi purpose. So wishing all of you guys a very happy and safe and enjoyable Holi with your family. Okay, so let's try to meet tomorrow with another beautiful questions. And for weekends, we have the bangers. And if you don't know what it is, then you have to know. So we basically plan to do a resume review of you guys only. And I will also put my resume, what tips, what basically strategy I have followed when from I am belonging from a tier 3 college, and from tier 3 college to getting Amazon's placement, and from Amazon to make a shift to Walmart to a senior positions. What actually the modifications I made to my resume when I made the switch, and what is my initial resume which is selected to Amazon from my college time, and this my senior positions shift resume has selected with multiple companies. I already told you guys, like Flipkart, Microsoft, Walmart, Cars 24. Yeah, and many more, like Allen Digitals, many more companies. I got the calls with my resume only. I will make a detailed video on that. But top of that, I basically want to do a resume roasting of you guys. So there is a things that we have opened a Google form. So if you want to do your resume to be reviewed by us, then please fill the Google form, and on that Google form we will make a something like of providing your resume, pass your resume with ATS score, and I will do a manual review your resume. And if your resume is like giving more than 80% score on ATS and it is fully parsed, and I am satisfied with the skill set, and you have put on your resume with the respective links you have put it, and the job IDs you are applying, you want to apply for Walmart, and they basically very suitable for your skill set you have mentioned, then I will obviously going to refer you the job IDs you are interested so far. So yeah, please, I will put the Google form links to this video's descriptions and this video's first comments also. So please find it out and fill it and post that. Let's meet on that video. Okay. So for that, bye guys. Bye.